we could kick start our session, I would like to have one polling to be done on two simple queries. Hope the participants will be able to respond to this polling. I will put the link in the chat box. Am I audible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Hello, friends. All the students and staff, are you able to hear me?
Yes, ma'am.
Yes.
Yes, ma'am, you are audible.
Yes. Is the link visible?
Yes, ma'am.
Participants, please, you can start giving your valuable response to both the pollings.
Ma'am, it is asking for some code, ma'am.
Is it so?
Yes, ma'am.
Is it in the mobile or
Mobile, ma'am.
mobile? Okay. I will show in my screen one. Others are able to answer? Those who are having?
Yes, ma'am.
Yeah.
Yes, ma'am.
I think the QR code, I don't know whether you'll be able to.
Ma'am, both the polls show the same question, ma'am.
The second question I will open. 1 minute. Could you please type this code? Those who are not able to, 635727 as the code. Those who are not able to open, otherwise it's okay, leave it, never mind. Still they are answering. I think I got around 38 votes. All right, fair enough. I think we can stop this poll and continue with our work. All right. So let us kickstart our session. I had some questions for you in that poll. Many of you have answered, what is artificial intelligence? And some of you have answered that you know about machine learning too. And very few have said that you have the knowledge of deep learning. Okay, today my job is very simple. I'm just going to introduce to you 5 terms, that's all. One is artificial intelligence, the second one is machine learning, the third one is deep learning, and one more topic which is the buzzword all around us. Can I just get a hearing from somebody? What is the buzzword of today's scenario? What is the term that commonly used?
Artificial intelligence, AI, ma'am.
AI, machine learning, and deep learning. Apart from that, what do you hear?
Robotics, ma'am.
Data science.
Data science.
Data science and Python, ma'am.
Yes. So the data science is a buzzword everywhere. So they either ask you when you apply for job, want to be a machine learning engineer or a data scientist. Now don't ask me what is the difference between data scientist and machine learning engineer. That is your homework to just check it out. All right. So today we will just try to understand these terms very clearly: artificial intelligence, machine learning, deep learning, data science, and Python. That is my role today. So to begin with, I also asked one question, which is a subset of what, and some of you have answered well. So this picture will give you the idea or answer to that question. So artificial intelligence is a set of programs which has the ability to learn like human being. Okay. So that is why it's called like human being, which is artificial intelligence. It's not exactly human being because that intelligence is induced by the techniques and the programs and code, the model that we built. So that is why we call it as artificial intelligence. So when we say artificial intelligence, it doesn't mean it is only robotics. All right. So it's a concept which could be applied, or it's a set of programs which has the ability to learn and reason like human beings. All right. Then what is machine learning? It's a subset of, see in this picture, I just want to give you the relationship between these 3 terms. Then I will try to bring in the data science to the same diagram and you will be able to relate. So machine learning is nothing but a subset of artificial intelligence. Okay, and deep learning is still a deep model. Again, it's a machine learning model. So it's a subset of machine learning. All right. Moving on. So we will try to understand each term one by one. So artificial intelligence, if you know, the father of artificial intelligence is John McCarthy. And he only defined the term in 1956. It is a science and engineering of making intelligent machines. Okay. So I have put this picture. Can we make the machine behave like human? All right. So that's all about artificial intelligence. Okay. So what are the applications of AI? These are some interesting ones which are familiar to you all. I have listed. So when you Google for some movies or anything for that matter, using your prior history, browsing history, you will get some movie recommendations. How they recommend, how Google recommend. So Google has a built-in AI system which helps to read your past history of browsing and try to recommend based on your taste. These are the movies that you would want to watch. So this is an application of AI. Then product recommendations. So when you want to buy something, you will see some pop-up ads coming up. So that is also through this AI. And Uber pricing, which we do use every day when we travel. So the pricing, you see varying pricing. Today you pay something and tomorrow you pay something else. So that is also based on various conditions that are around. The traffic density, the weather conditions, all these play a vital role in this Uber pricing. Again, it's an application of AI. And you are fascinated by this chatbots. So some of the bots that what is a chatbot? Chatbot is nothing but a bot with voice integration. All right. So you have seen all these bots. I have put the pictures below. Can you just name what are those bots that I've listed down? The first one is
Google Assistant.
yes. The second one,
Siri.
Siri. Yeah, correct. The third one, which is a
Alexa.
common one in every home.
Alexa.
Opera.
Alexa.
Yes, Alexa. And the fourth one, what's the fourth one? Not very familiar. Is it Cortana? Microsoft's Cortana, right? So these are all chatbots that we see around us. And of course, in gaming, we see AI. The very first game that was started for AI practices was, any guess? Any guess? The first game which used AI.
Virtual reality, ma'am.
That is very little later. Tic-tac-toe.
Yes, ma'am.
Yes.
We can play with the computer.
Yeah. So actually, that was the first example. They were venturing out for checking whether the role of AI would help in improving the algorithm. So now, somewhat we have just placed what is AI, right? So bringing the intelligence into machine. That is what is AI all about. Now we'll try to understand what is machine learning. So here you see that humans learn through past experience. So we learn many things over time. Initially we struggle and we become little better and we become later really smarter, right? So we learn from past experience. How about computers? How do they learn? They learn by following the instructions that we give, isn't it? So the question is, can we make computer also to learn from past experience? Any guess? So I have given you two terms. Human beings learn from past experience and the computers learn through the instructions that human beings provide. So now the question is, can we make computer too to learn from past experience?
Yes, ma'am.
Yes. How?
That is what is AI, ma'am. It identifies what a person is interested in or what they've pastly searched for. Example is Amazon, ma'am. If you search for one particular thing, they start recommending you things related to that.
So through what? So what does a past experience mean over here? It is
Ma'am, data.
Repetition.
yes, data precisely. We can give real applaud to the one who answered as data. So we can make computer to learn from the data that we provide. So you were answering that it is AI. It's basically machine learning. So we can make the computer to learn from data And that is what is called machine learning. Okay, right. So if you want to relate AI and machine learning, so that intelligence, we said learning or making the machine behave like intelligence, I mean, human being, we said. So that intelligence that we see in the term artificial intelligence is through machine learning. So this machine learning is nothing but a set of statistical and mathematical tools to learn from data. All right. So what is the flow of this machine learning technique? You have ordinary system. If you have just an ordinary system, we are not going to achieve much. Maybe it will be like it will behave like your calculator. All right. Now, with the introduction of AI, so when we say AI, we are going to induce intelligence into the machine. So when we talk about the inducing intelligence to the machine, it is through the machine learning techniques. All right. So through this machine learning techniques, we are going to make the machine learn. All right. So once the machine learns, we have to know whether it's learning correctly or not. So we have to provide some testing. And when we try to test whatever it is learned is correct or not, then we try to improve. If it is not okay, then we try to improve, right? So this learning aspect is nothing but the modeling. Okay, so we build the model and make the machine to learn and predict whatever through the model, whether it is able, we check whether it is able to predict correctly. And if it is not able to predict up to our expectation or to a certain expectation, then what do? We try to improve this learning by altering this model. Again, we try to test it and make it to predict something. And if the prediction is okay, then we try to. And it's never a static model. Always it will undergo a lot of iterations so that the predictions will be better anytime. And understand that you cannot expect the machine learning model to be 100% accurate. Usually it will be 70 to 80%. If you are getting above 80%, that means the model is good. Okay. So basically, what is this machine learning model all about? So you have some input and you expect that input to result in some output. So this input is treated as X and the output is treated as Y. All right. See, for example, if you see a particular fruit, if it is red in color, if it is somewhat, what do you say, it's not very soft, and it looks like one round shape, then you can just say it is, and red in color, maybe you will think that it's an apple. All right. So the size, the shape, the color I mentioned, all these are going to be input, right? So that is your X. If it is a mango, the color will be yellow and the texture will be soft and the shape will be somewhat different. It may not be always round, correct? So these are the things that are going to be acting as an input. We call it as features, feature vector. So now it has to tell to us that this is apple, this is an apple, and this is a mango. So how we are going to do that, right? So that is called modeling. So basically, we are trying to find out what that model is. So in my equation, X is your input, and you want the result to be Y. So if this X is going to have these parameters, I have to say that this is an apple. If X is going to be these parameters or these attributes, I'm going to say that it's a mango. So what is it, how we are going to do that? That is your F. So if I can fix that f, that is the model, right? It's a function of x. So I have to build this model so that when I train this model with many inputs and afterwards I try to give a new set of attributes, it should correctly tell me, okay, this attributes belong to this particular fruit. So that's all about the machine learning model. All right. So we have the model depicted over here. So you see the training phase. And what are we training? We are training with features. These features are nothing but your X I mentioned. All right. So when you're training, you're trying to understand and build a model that is your F. All right. So once you finish, of course, you have to have some kind of labels so that you'll be able to train this model and try to test it. When you try to test it with new set of features, and it has to use this learned model and predict the result. So if the result is what you're expected to have, then it's fine. Otherwise, you have to undergo the same process again and again, then by fine-tuning your model till your predictions are okay. So you're going to have two sets of data. Basically, one is training data, the other one is testing data. And later on, you will understand when you're building models, it's not just all about giving only the things that are actually right. When you're training model, you have to tell the model that these are not fruits also. So that will help the model to effectively learn from the features. All right. So now the third term, that is deep learning. Usually in machine learning, the transformations that we learned over here, y equal to fx, will be a linear transformation. What do you mean by linear transformation? It's not that difficult to build a model. With some linear steps, you will be able to, one or two steps, you will be able to achieve the predictions or model, right? So what is deep learning? Deep learning will be having multiple such layers, all right? So it is basically non-linear transformations. It's not going to use just a vector. Instead, it's going to have something like non-linear transformations like matrices. A good example for deep learning will be images and video sets. So image can be represented as a matrix of pixels. And when you submit that as an input, image as an input, it has to learn from the images. For example, feature extraction from a face will involve first the normal features and then complex features, and finally the model should be able to identify whether a particular image is a face image or not. All right. So that's all about deep learning. So it involves just not linear transformation, but non-linear transformations. So it involves many steps, many hidden layers, and then finally it will arrive at the predictions. Okay. So this is a simple example of the deep learning model. So you have the input. So suppose the input is a car. So the machine should extract the features from whatever we are giving as an input. The input could be any kind of input. It could be image, or it could be, usually for deep learning, we will not go with categorical data. So usually it will be higher type of data. That's why we say non-linear, right? So once the input is given, the feature will be extracted and the model can be learned, and that is a classification model. Finally, the model should tell us whether it's a car or not a car. So it is generally called binary classification because it's going to say either yes or no. It is also possible to have multi-layer classification. So multi-class classification. Instead of just car, you can also have other entities as input, like Jeep and other vehicles. If your entire model is for vehicles, then that becomes, if you're getting the output as different types of vehicles, then that becomes a multi-class classification. All right. So if it is normal machine learning, if you observe in the first image, only one layer is the hidden layer. So you have an input layer, you have an output layer, so you have only one hidden layer. Whereas when it comes to deep learning, you will have multiple hidden layers so that you will be able to learn the features in depth and you will be able to classify. So that's about deep learning. All right. So actually, from 2015, the computers started out performing human being. All right. So I'm going to take you through one simple example to understand actually what the machine learning mean to us. So this is about some music. All right. A particular person. This is like he likes something which is very fast and really soaring intensity music. All right. So he doesn't like very relaxed and light music. All right. So how do we recommend a music to a particular person, right? So a simple way of addressing this problem is to just plot the tempo of the music as x-axis and the intensity of the music as y on the y-axis. So you can scale it from relaxed to fast in the tempo on the x-axis, and the intensity like very light to soaring intensity on the y-axis. Okay, so now there is a music, right, and which is very slow, right? That is very relaxed music. That means the tempo is very relaxed, and the intensity of the music is very light. So where will you see that? You will see in the lower part of the quadrant. So the red dot, one of the red dots will tell us the music is very relaxed because it will come somewhere here. And the intensity of the music, the sound is very low. So you will get somewhere here. So you can decide definitely this kind of music will not be liked by that particular person. Now, so how about these music that I have put as green dots? So they're all fast in tempo and the intensity is also soaring intensity. So you know if any music of these category will be liked by that person. All right. Now, suppose we have you see this image down. Suppose you have a music which is of average intensity and average tempo, whether the person will like or not. How do you decide? So what do we do? Right? Are you seeing the dot over here? Can I have some response?
Yes,
Yes,
ma'am.
ma'am.
Yes. So now one music is of average tempo and average intensity. So how do we know whether we have to recommend this to that particular person, right? One simple way is to just draw or collect points that are around that music, right? So the music is placed over here, this gray dot, and around this, try to collect the neighbors, all right? So when you draw a circle around it, what do you observe? You observe that 4 of the liked ones are within the circle. 4 music that will be that was liked by this particular person or that would be liked by the particular person is within the circle, falling inside the circle. Whereas only one neighbor of the dislike is falling into this circle. So now the question is, will this person like the music or not? Can I have some answer and with a justification? Will you recommend this music to that person? Can we recommend? Hello, students, are you hearing me?
Yes, ma'am.
Yes. So can I have some answer? What is your opinion, whether this will be liked by the person, whether we can recommend this?
Yes, ma'am, he will like it because he searched for these kind of music, which is relating to the dot.
No, he relating to the dot.
The middle one, yes, ma'am.
Okay. So any other answer? You're right. Any other guess?
Ma'am, alongside with recommending the songs that have come out to be the topmost choice, ma'am, alongside that we can recommend the lower ones also, ma'am. The green dots in common, because that might also be their choice, ma'am. Relatable.
No, see, you all didn't catch the point. See, what I'm trying to say is the green ones are the ones usually liked by that particular person, right? Person X. And that particular person does not like the red dotted ones. Okay. It's very clear that if it is of high intensity and fast in tempo, definitely he will like it, right? Whereas if it is low and low intensity and very relaxed music, he's not going to like at all. So it's as simple as it. Now the problem is, one music is of average tempo and medium tempo and average intensity. All right. So it is neither among the green dots nor among the red dots, right? It's in between. Now the machine should decide whether, see, it's a machine learning technique, all right? So it has to decide whether we can recommend this music to that person or not. So how will it make this? Simple way is to just collect, draw a circle. We as human being, we can figure out all these and then do it. Of course, this should be translated as algorithms so that the machine will be able to do the same job what we are doing over here. So what we can do is we draw a circle around this gray dot, right? It's actually B because it is not seen over there. I'm just putting it as gray dot, right? So when you draw a circle, you are able to see that within the circle, most of the musics that are liked by the person falls, whereas very less number of points that are disliked the person by the person falls over there. So if you see there, only one dot which was not liked by the person is falling there, whereas four dots, which are four music items, which are liked by the which are four music items, which are liked by the person falls over there. So naturally, when you collect the neighbors, whichever is more, the decision will be for that particular choice. So naturally, what will the machine do? It'll recommend or not?
It will recommend,
It
ma'am.
will
Yes.
recommend.
So it will recommend. So that's how the machine learns. Is that clear? So this kind of algorithm is called K nearest neighbors algorithm. All right. Have you heard of this? K nearest neighbor? All right. So what is the problem over here? What is the problem you see over here? Can somebody tell, is there any problem or everything is fine? Is there any problem or everything is fine?
Ma'am,
Hello.
problem regarding the recommending of songs by the machine, ma'am.
So what do you see over here? See the samples that you are seeing for the dislikes are very less compared to the samples that we have for the likes are more. Correct, no? So
Yes,
very
ma'am.
few dots for this. So definitely the learning may not be precise. Is that clear? So if the data is more, the model that the machine learns will be better and you can expect higher accuracy. So the samples that we have for training the model plays vital role. So this is a very simple example of machine learning, all right? So what are the types of machine learning? Basically, there are three types of machine learning. One is supervised learning. The other one is unsupervised learning. The third is reinforcement learning. Okay, we will try to check upon what are these terms mean to us. I'll start with a simple example. All right, what is supervised learning? So the supervised learning is all about labeled data. So the key term for supervised learning is labeled data, right? So the answer, you know what it is, and you are telling the machine that if these features are there, it has to be this one. So you have to teach the machine that these features which should lead to this. So the label, so the why is known over there. So that's called supervised. That's why it's called supervised learning, labeled data. See, for example, I have here a set of coins, right? So the first one is if it weighs 3 grams, then it is a rupee. All right, 1 rupee coin. Though 1 rupee is not valued anymore. So just an example. So if a coin weighs 3 grams, then it will be a 1 rupee coin. It will be classified as 1 rupee coin. Similarly, if a coin weighs 7 grams, then we call it as euro. All right. So we tell the machine if it is 4 grams, then it is a dime. All right. So this is how we train the machine. So how do we train? Some input we give. What is the input over here? The weight. So the feature over here is weight. So I showed you one example, y is equal to f of x, isn't it? So that x is nothing but the feature. So for this, what is the feature that I have taken? The weight,
Wait.
right? So, and what are we telling over here? If the weight is 3, then you have to identify it as a rupee. So that rupee is a label, Y. All right. Similarly, if the weight is 7, then the coin has to be a euro, right? So if it is 4, then it has to be a dime. So once you do this, that's your F. So you have mapped it. So once you finish this mapping, and suppose some new coin comes into picture, so it will just check the weight. If the weight is this, it will automatically classify. So without the help of the human intervention, because you have trained the model, now you just put the coins, bunch of coins or bundle of coins into the machine. It will segregate them as which are all rupees and which are all grams and euros and which are all dimes. Okay, so that's about supervised learning. So you have the features and you need to have label. All right, so that's all about supervised learning. So it's labeled data. Now we'll take another example for unsupervised learning. So we have a table, though the entries are not there, and the table consists of the players. Maybe you can take it as cricket players, and you have the runs scored by the players and the wickets taken by those players. Okay, and nothing is said about. this. So what we do is, we don't know, we don't have labels at all right? So what do? We want to understand this data and try to identify how you can group the players, all right? So one way is to plot. You can, because only two attributes are over here. What are they? Runs and wickets. So we plot runs on the y-axis and wickets on the other axis. So now the blue dot says that, what do you say about the blue dots?
The wickets are more than runs.
They have taken wickets more but scored less runs.
Less runs.
Yeah, that is another observation. Similarly, what can you say about the red dots? You see that they have scored more runs but taken less wickets. So all the players' data was plotted. So there are some 6 players in this category and they are totally separated, right? So there are 2 groups now you can identify. So what can you say about the blue group?
Ma'am, there are 6 bowlers.
Very good. Yeah. And
5 batsmen.
Yes, 5 batsmen. So what did we do? We classified the data. We didn't know anything about it earlier, right? So nobody told you classify it as bowlers and batsmen, but still we could do it. So that's about unsupervised learning. So that's called, that's based on unlabeled data. So the key term for supervised learning is labeled data. The key term for unsupervised learning is unlabeled data. Now okay. So now the third type of, there was some disturbance, so I was waiting for that to close. Thank you for muting. Now the next one is, the third type of learning is reinforcement learning. Okay. So if you recollect, when you started walking, your first step, your mom or someone close to you would have been nearer to you, and they would have definitely given you something like a reward if you walk properly, right? So when you stood first and took your first step, you would have fallen definitely. To make you walk consistently, so they would keep a toy somewhere ahead of you, so that you will be able to reach the toy, or a toffee somewhere that side, so that you will be able to reach that toy or toffee, right? So what is that toy or toffee called? It's a reward, isn't it? So the same thing you can relate over here. Reinforcement learning is all about rewards and feedbacks. So there is an agent, right? So the agent is able to perceive the environment, right? Whatever environment that is around. And based on the environment, the agent will be able to take action. And once the action is taken, it has to be viewed, right? And interpreted. Once the action is correct, they should be given a reward. So it's not only always a good, reward for doing it good. When the agent goes wrong, we have to give a feedback also that this is wrong. Then only the agent will be able to correct and interpret the feedback and change the state, so that again he will be able to take corrective measure, so that the next, when he takes action, when it is reviewed, it will improve, right? So that's all about reinforcement learning. So you have a model, uh, um, and you will have an output. You should give the feedback based on the output, whether it is correct or not. So if it is not correct, or if it could be improved, based on the feedback, the state will change, keep changing iteratively till the predictions are somewhat okay to an expectation. So a good example for this reinforcement learning is auto parking. Okay, auto parking of vehicle without the help of any human intervention, right? So based on the feedback, you get like beep sound and other things. So those are the feedback. So if you want to put the entire machine learning model, it's just these things, 4 terms: the input, model, output, and based on the output, the feedback should be supplied to the model. And again, you have to keep observing your output. So this is all about the machine learning model. So what is the relevance of machine learning in present scenario? You get, you see loads of transactions that are happening because of the web, and so you see the humongous data getting generated. You have cloud for storage, and so more memory is available and more computing power. So that's why all these have brought in this concept called machine learning. Okay. So since you're sitting for a long time, I would like to, give you this simple quiz. Hope you will be able to participate in that. I'll put this quiz in the chat box. Try to answer. Students, you are able to see the quiz?
Yes, ma'am.
Yes. Please try to answer. Done? Complete?
Done, ma'am.
Done? Okay. Can I have your hands raised if you have done? Then we can proceed with the rest of it. The participants, please raise your hands if you are done. Okay. So any queries? Shall we proceed, or you want some queries to be answered after this? Hannah ma'am, can I proceed?
Yes, ma'am, I think we can proceed.
Yes. Okay. So having understood what are the types of machine learning, now we will move to some of the machine learning techniques, and whatever I'm discussing are very simple and basic techniques. Maybe you can explore the rest of it later. Uh, I have here one example about whether to buy a house or not. All right. Suppose in a particular area, the price of a house go like this. So if it's a small house, it goes for $70,000. If it is a big house, it goes for $160,000. Now the person wants to buy a medium-sized house. Okay, so our machine learning model should tell us whether what is the price we can give for a medium-sized house. So how do we do that?
Ma'am, we can add the big house price and small house price and divide by 2.
That is average, right? You mean to say average? Okay. The usual technique under machine learning, as I mentioned, more the data, better the model, isn't it? So generally what they do is they just collect the data. Always when in machine learning, when the problem is given, we have to address the problem based on the data, right? So collect some past purchases, all right? So the blue dots that you're seeing in the graph. So the best way is to just take paper and pencil and sit and plot, okay? So you have on x-axis the size and on y-axis the price of the house. So the size, medium size, I have plotted over there, the blue dot, it says 70,000. So similarly, all the dots say that the size is that much, and the intersection will tell you what is the size, where it stands. And the y-axis will tell us the price, corresponding price. Now, the size of the house that I would like to buy is that the one with a question mark. So the size of that house, you plot it on the x-axis. So I have placed it over here. All right. Now, what should I do? I should draw a line, intersecting line, and go try to intersect with the y-axis. So wherever it meets, right? So you can take that and try to say that would be the price of the house. So if they are quoting that one, then you should be happy to take that house. So what is the best price you can give, you can think of? So as I mentioned, you take it straight up and try to intersect with the y-axis. So somewhere around 8, you are able to meet the y-axis. That means it should be around 80,000. I don't know whether I've drawn correctly. No, I have to go still up and then see where it meets. All right. So we have to draw a line and intersect, right? So if I just drop the line over here, I think it will go somewhere around this place. So between 10 and 15. So it would be nice if we could just get that house for 1,20,000. See the line. So what are you doing? You are trying to draw a line, somewhat trying to fit the points that are existing over there, right? So then you try to draw a line, you will be able to precisely meet the prediction. So here, once you draw this line and then you try to take it up on the intersecting line to meet this line, and then you try to draw an intersecting, from the intersecting point to the y-axis, you will notice that it will be $1,20,000. That's the correct price of the house. So how did we do this? This is called linear regression. This technique is called linear regression. So just plot and try to connect the points. So those points are nothing but the past data. The points that you're seeing on the screen are past data. So try to manage to draw a line connecting these points. If you are able to achieve that, it's not that easy as you look at in the figure. So you have to draw the line in such a way that the error will be minimized. All right. So you're able to predict the price of the house based on this simple technique called linear regression. So the very basic machine learning technique is linear regression. Okay. Now, as I mentioned, it's not possible always to draw a line. What if the points are like, as it is mentioned over here, then you can try to draw a circle, right? That's also a model. If it is not, so we call these as non-linear techniques. So if it is not a circle, if it is going to be like this, then it is called polynomial. So these are called polynomial regression. So if the data is not falling on a straight line, you have to think of some other techniques, and the next set of techniques are called polynomial regression. Okay. Now we'll move to the next example. This is just to check whether how we can detect a mail as a spam mail or not. Okay. So the past data says that when they studied the data, they just saw that these 25 mails were classified as spam, and the 75 mails were classified as non-spam. And when they took the spam mail and saw it, they could see most of the mails consisting of this word cheap, right? So if a mail is considered as, contains a word cheap, there is a possibility of being classified as spam mail. Okay. So the word cheap is a key term over here. So when they observed, opened the mails and checked it, they could see that in the spam box, out of the 25 mails, 20 mails had the word cheap. Whereas in the non-spam set of mails, still 5 mails had the word cheap. All right. Okay. Now this is the data that we have. Now how do we decide when a new mail comes whether it has to be classified as spam mail or not? Okay. So what is the thing that we can look for? We can look for whether the word cheap is present or not. All right. Is it the only decision making attribute? Let us try to understand. So how it is done by the machine. So what is the algorithm that would help? So when you analyze the data, you see that 20 out of 25 spam emails contain the word cheap, and 5 out of non-spam mails also contain the word cheap. So what do we do with this? So we try to take all the mails that are having the word cheap. Okay, so 20 from the spam, 5 from the non-spam. So what do you see there? There are totally 25 mails, that is 20 plus 5. 25 mails contain the word cheap, right? So out of which this 20 out of 25 of the spam mails contain the word cheap. Is that clear? So that means 80% of the time it could be, what is the probability? It is 80% means 0.8, right? Because the probability will be always between 0 and 1. So 0.8 is the probability, or 80% of the time, if any mail comes, 80% of the time it will be treated as a spam mail. Okay. So how can I say that 80% of the time? So that means this is not sufficient to decide whether a mail is spam or not. So that means what? We have to consider more features. So what are the other features that we can consider? You can take spelling mistakes. You can consider maybe missing title. All right. So these things will act as additional attributes to decide whether the mail is spam mail or not. So what are we associating over here? Conditions, right? So this is called conditional probability. So whenever you have conditional probability, the term comes into picture is Bayes algorithm. So this algorithm, the technique that we have used over here is a machine learning technique called naive Bayes algorithm. All right. So we have seen linear regression. We have seen polynomial regression. Now we have learned one more technique or one more machine learning term, which is naive Bayesian algorithm. All right. So now we'll move on to one more, which is one more algorithm, which is decision tree algorithm. Okay. So I have a data listed over there. This is app recommendations. Okay. Or app, the past data says that these are the apps that were downloaded by this age group and this gender. Okay. So you know the logos, Pokemon Go, WhatsApp, and then Snapchat, isn't it? So gender, female, male, you have an age group listed over here. Now, the question is, between the gender and age, which is the decisive factor that will help us to predict what app to recommend or not? Is my question clear? So which is the decisive factor? There are two factors over here, gender and age. So which one will help us to decide what app to recommend? So when you look at the data over here, suppose I take only females. Suppose I presume that I will go by gender. So female, female, female. And if you look at the app, what do you see there? Females have downloaded Pokemon and they have downloaded WhatsApp also, right? That means you're not able to decide much. Whereas when you take the age group, if you see, the Pokemon Go was downloaded by an age group who are below some 20, all right? Below the age group of 20. See, 15, be it a female or male, they have downloaded Pokemon Go. So that means, which is a clear-cut decisive factor over here, age. So what I would do when somebody is looking for an app, I mean, if somebody is browsing for an app, then if the age group is below, if they are under the age group of below 20, then immediately you can go for recommending Pokemon Go, right? Okay. So if they are above 20, you see here, WhatsApp is being downloaded by females, whereas Snapchat is being downloaded by male. So that means if they are above 20, the gender becomes a decisive factor. So if they are above 20, female means you can give, recommend WhatsApp. If male, you can recommend Snapchat. This is a simple example. All right. So this kind of decision making give rise to a technique called decision tree algorithm. So this is also a machine learning technique. It is not going to be so simple as it is listed over here. You know, you are dealing with only some 5 or 6 records over here, and it's easy to understand. Generally, it's not. In reality, it's not that easy. Okay, right. So the next is we'll try to understand one more machine learning technique, acceptance at an university. All right. So when you apply, they look at two attributes. One is the entrance test marks. The other one is the grades that the student has scored in the previous exam. So if a student comes with the entrance test score of 9 out of 10 and the grades 8 out of 10, what is the probability of him being accepted in the university is perfect. Whereas, if it is low grades, like 3 out of 10 in the test and 4 out of 10 in the past grades, definitely the student will not be accepted. The problem is if they are in the middle. So what is the prediction that you can give whether this person will be accepted in the university or not? So as usual, the past data of students admitted into the university is being plotted over here. All right. So the red dot says that these students were rejected and these students were accepted. So as usual, this one talks about x-axis. You can say that the test scores and y-axis grades scored in the past exam. All right, entrance test and the past grades. So now the green dots say these were accepted and the red dot says they were rejected. All right. So the first thing that we would do is we will try to draw a line. So if we are able to fit a line, as we mentioned, it is linear regression. Okay. So you can just check if the line can be drawn, then which one to reject. Anything below this can be rejected and anything above can be accepted. Okay, right. Now, so but even if you draw the line like this, can you just tell me what does this mean to us? See, it says that I said x-axis is the entrance score. Entrance is 9, fine. But you see the past year grade, it is 1. So that means you failed in your previous exam, but your entrance test score says that it is 9. Is it correct? Is it correct? Is it practically, is it possible to accept the person in the university? Can I have some answers? Suppose you failed in the previous exam and you score excellently. You have this entrance test, isn't it? CET and other things. You score 99% in the CET and you have failed in the 12th standard. Will you get admission can you get admission in the engineering college or medical universities? Hello?
Yes, ma'am, we can hear you.
Will they give you admission in reality?
No, ma'am.
No.
No, ma'am.
Yeah. So that means this technique is going to fail. So how should so we have to change our learning. So all these dots that you see over here should be rejected because these dots say that though it is higher entrance test score, they have failed because minimum you require 50%. So all these dots have to be rejected from this criteria, removed from this criteria. So that means this line is not going to help us. All right. So the same thing is applicable over there. If they have scored even 100 in the school grade and they've scored very less in the NP and all, these points cannot be accepted. So what do we do? So it's going to see these are the dots which cannot be accepted, and these are the dots that are going to be rejected. Okay, so that means it is going to look like this. So what is the solution? So if you look at the picture, you're seeing the green dots over here alone. This part of the quadrant alone should be accepted. The rest of it cannot be accepted. So drawing straight line, one line will not solve the problem. So you need one line to partition like this, another line to partition like this, and take only this point, right? So this is basically your neural network. Okay, so your logistical regression, your polynomial regression, your linear regression, your decision tree, nothing can help in this kind of problem. So it's not a very simple approach. So the learning should be based on some kind of intelligence. So what is that, or what is that? That's nothing but simulating the brain. So that's all about neural network. Okay, right. So when we started with drawing the line, we said we just try to fit the line. How do we know that the fit is a good fit or not? So I have a simple example. There are 3 dots over here, right? Green dots, and there are some red dots. So these signify one group of data. These signify another group of data. So what is the line that separates, line that best separates these two data sets of data? So there are 2 lines I have drawn over here. One is blue shown over here. One is purple or black, you can take it as. The other one is yellow line. So among the 2, which one will be better? Any guess? Both are separating the data, isn't it? So which line is better according to you? Hello? Can I hear from someone? Purple line or yellow line? Participants, are you hearing? Am I audible? Yeah.
Yes, ma'am.
Yeah. So among there are 2 lines you're seeing. One is darker line, which is also separating the data, the blue dots and red dots. Similarly, you have one yellow line that is also separating the data. My question.
Ma'am, we can't see the screen and can't hear you also.
I think there's a problem with ma'am's connection. Please wait. Yes, ma'am. I
Yeah?
think you can share your screen, ma'am.
Yeah, I think there was some interruption. Are you able to see the screen?
Yes, ma'am. Yes, ma'am.
Yes. So sorry about it. I think there was some disruption. Fine. See, I was asking a question, isn't it? I was not hearing any answer. There are 3 dots, green dots, and there are 3 red dots. And these talk about, the data talk about, there are 2 groupings over here. And how do we separate these 2? So one way is just to draw a line. So here we are seeing 2 lines separating. One is the darker line and the other one is yellow line. Both are separating over here, these 2 points. Among the 2, which one you feel is better is my question. Can I have some answers? Are you hearing me? Hello?
Yes, ma'am, you're audible.
Yeah, audible. Okay. So any guess? It's just a guess. Which line is better? The
Yellow
dark
line, ma'am.
Yellow line is better. How? Can you just help me out? How you feel that it is yellow is better? Okay. Suppose you imagine that you're twisting the yellow line slightly up. What will be the problem? You're taking the yellow line up. What will be the problem?
The green dot will come down.
Yes. So, whereas if I slightly take the blue line up, will it affect? No.
It won't.
Right. So that's, yes. So definitely, which is the correct, which is the better line? The darker one. The reason is when you are trying to separate, you have to separate in such a way that it will maximize the distance between the boundary of the points and the line. Okay. So now if you look at the distance of the green dots with the yellow line. So you try to, in this figure, I have drawn those distances, right? So from this green dot, you try to take a distance to the yellow line. Similarly, from this green dot, try to take the distance to the yellow line. And all the 3 points, you try to take the distance to the yellow line. Similarly, do the same thing with the darker line. So when you take the distance, you're going to get some numbers. And if you try to add those numbers and see if it is going to be minimal, then take that line. So that means the distance between the boundary points and the line and the error which separates these should be minimal and the distance should be maximized. Okay, so the error can be measured. The error that you would like to measure is nothing but the distance between the boundary and the points over there. Okay, so this technique which helps us to maximize the distance between the boundary points is called, see, these are the data, more data over here. So this is one line and this is one line which is separating. So if you choose something in between this path, all right, so these are the boundary lines. Okay, so try to take a line that is in between this. See, this is actually called a surgeon's technique. When they try to perform surgery on a subject, they have to be very careful with the other parts of the body, right? So they have to operate by maximizing the distance between the boundaries and minimizing the error. So this technique is called support vector measurement. All right. Okay. Right. So on the same lines, suppose I have these 4 points, right? 2 red dots over here and 2 green dots. If you try to draw a line, you will not be able to achieve the result. See, for example, if I draw a line straight, then all of them will fall on the same line. If I try to draw a line like this, 1 red point, 1 green point will go there. 1 green and 1 red will come below. So there is no way you will be able to use the line to separate them. Then what is the other way? So you can think of curves, right? How I said linear regression and polynomial regression, here you can have the curve. And you have to look at in a different manner, and you have to identify some way of separating this from this. So if you look at this curve will separate. So you have to fit a curve like this, and this kind of technique is called kernel trick. All right, this is another machine learning technique. So now we are almost coming to the close of the machine learning techniques, because I have to move also, right? So this is a little interesting example. Suppose the pizza giant wants to place some 3 parlors in the city. So how do they go about? So they will try to use the data of the purchase that were made by the customers. So these are the areas where usually in these areas, the black dots, they buy the pizza. These are the pizza eaters. So what they will do is they will try to bring one, they try to just fix 1 parlor over here and 1 parlor over here randomly and 1 parlor over here, but randomly. Now, they try to understand the distance, they'll study the distance. So whichever is closer to this parlor naturally will go to that parlor, isn't it? The houses that are closer. So when you try to see this dot will go here, this dot will go here, and this house will go to this blue parlor. The house that is here will go to this parlor. The house over here will go to this parlor, right? So they try to cover the houses that are closer. And so once they cover the houses, you will see that these yellow houses are nearer to this. These blue ones are closest to this blue parlor, and the red ones are closer to this red parlor. So now when you look at these, the star, that is the position of the parlors and the houses, you feel that it is good to move this yellow one to the center of the houses who are buying the pizzas from that particular parlor. So they try to move it to the center, right? The moving to the center is nothing but trying to find the average distance, right? So the mean of the distances of these. So, and they try to bring that to the center. So these are all iterative process, right? So when they bring it to the center, it look like this initially. Then you observe that these blue dots are closer to this, right? So you try to bring the average of, find the average of these, collect the neighbors. Similarly, collect the neighbors for this blue. So it will keep changing, right? So over one iteration to another. So keep repeating by bringing it to the center. So this is called k-mean clustering. Okay, so move the center, keep doing this repeatedly. Finally you will achieve a better result, so that you will identify the location of the parlor, which will optimize the number of buyers to that particular parlor. So this continuous iteration and finding the average is called k-means clustering. Okay, so we have learned many machine learning techniques. Since we are running short of time, I will try to move the next one. I'm just skipping hierarchical clustering. Okay. So I have one more polling, which I think we don't have time right now. It is just to now to take a polling of what is your stand, whether you have learned these terms or not. So maybe I will give this to you later. I will move to Python because we said we will cover Python. Okay. So what is Python? How many of you have heard of it? You have already answered in the poll. So Python is an open source software package which can be downloaded onto your system very easily. Right today itself you can download, because it is magic for computer science students. Anything that you want to learn, you can learn, go through this Python, do through Python. Okay. So, and you will be really amazed to see that you would have written long set of instructions to perform simple tasks, right? The same thing can be achieved in very few lines because it is a scripted language. So the features are listed over here. It's an expressive language. It is an interpreted language, and you can write. There are various versions of Python: C Python, J Python, Java Python. So it can be easily integrated, and you have a good GUI. Okay. Above all, the libraries that it has is very rich. Uh, is it fine now?
Yes, ma'am. Yes, ma'am.
Yes,
It
ma'am.
is in the screen.
Again, it is telling the same error code, error number 1. Okay. All right. So were you all there when we discussed the features of Python?
Yes,
Are
ma'am.
you
Yes,
hearing
ma'am.
me?
Yes, ma'am.
Yes, ma'am.
Yes.
Yes, ma'am.
Dynamically typed, that's most important.
No, ma'am. That is when your connection is
Okay.
lost.
So what do we mean by Python is dynamically typed? Um, in all the other languages you would have seen in the beginning or somewhere before usage we declare the variables, isn't it? But here we need not worry about declarations and also the type of the variable, the one that you assign at that point of time. Suppose I say a equal to 10, then be treated as integers. And suppose I say a equal to list, then the same a will be considered as a list variable. So we need not worry about the type of data, as in when we assign, it assumes or presumes the type of data. So that's the beauty of Python. It's also object-oriented language. Okay. Are you able to hear me?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Right. So now we will move to, I said I will definitely help you to understand data science, right? So data science draws the techniques of artificial intelligence. Okay. Can somebody tell me what is, according to you, what is data science? Hello?
Yes, ma'am.
Yeah. So can
Collection
someone
of
tell me,
raw data, ma'am.
uh, collection of raw data? Fine. Then what do you do with the data?
Managing of data collected.
Yeah, okay. So let me put this way, the steps involved in data science. Uh, for example, I have this data, right? So when I see this data and show the data to a particular, this is an expenditure of a particular person over 3 months. If I show this data, what you can tell, what you can understand, will you be able to understand and grasp anything quickly?
No, ma'am.
No. So you know that there are days listed, and you know the expenditure in rupees listed for 3 months, April, May, and June. All right, that's all you can. But will you be able to analyze the data? No. Same thing if I try to, the same data I have plotted in the curve, in a graph, sorry. So by looking at this, what can you say?
Ma'am, which day he has spent more money, you can analyze
Yes.
and
By looking at the graph, what can you say? What will you understand? Can you not say that the first few days of the month, the expenditure is high, and also the middle, that is after 10th, the expenditure goes high, isn't it?
Yes, ma'am.
Yes, ma'am.
Yeah.
yes,
So
ma'am.
this is all about analyzing the data. So if you just show a particular person or your boss in numbers, they will not be able to understand anything. So you need to analyze the data in a different manner and try to show them. Maybe this expenditure graph will help the person to reduce the expense, or you can also look at as, oh, I'm spending less during these days, I can increase my expenditure during this part of time. Okay, so it depends on the perspective on which you are trying to analyze the data. All right, so coming to data science, you will have a problem. All right, so the problem should be addressed. So when you want to address the problem, you have to follow various steps. For example, you are running a business and suddenly you feel that you're not showing any improvement in your business. So what do? This is a problem for the business.
Ma'am, we can't hear you, ma'am.
Please wait, girls. I think there's a network issue.
Okay, ma'am.
Yes. Okay. Sorry once again for the problem. Okay. So did you all see the graph that we
Yes, ma'am, we did
discussed?
see.
Yes?
We saw the graph. Yes, ma'am.
Yes. So, what is data science all about is when you are having some problem, as I mentioned, suppose you are running a business and you are not having any profit in the business. So, that means there is some problem. You have to address that issue. So, what do? You try to take that as a challenge and take all the data, past data, and just look at the data, analyze the data, and try to figure out what is wrong. And how do you do that? You have to build some kind of model, and try to see where the problem is and address that problem and try to overcome the issue by solving the problem, right? So the same thing, if you want the machine to do, right? So we have to bring in this concept called intelligence. That intelligence is through the artificial intelligence techniques. So machine learning techniques will help us to solve that problem. So that is the data science. So it involves problem, it involves data collection, it involves modeling, and it involves predictions. And not only them, it involves even visualization. As I mentioned over there, just listing the data and showing it's not going to help us. You have to visualize the data. Visualization could be any way. As I mentioned, I showed you one graph, right? You can use any kind of visualization technique. You can plot it and then understand the data and look at the key areas where you can improve the business, right? That's about data science. Okay. So this is a simple example of how Google uses data science for search recommendations. So when you type, suppose you want to search the keyword data science. So if the moment you type the 4 characters followed by 1 space and SC, you see the help that comes. This is called autocomplete feature, right? So this is actually based on the machine learning model. So the Google uses data science to provide relevant search recommendations. So this auto correction is on autocomplete. Sorry, the feature is influenced by many features. It depends on the geographical location and the phrase, the keyword, and the query volume, right? So all these are used to influence this autocomplete feature. So this is an example of data science. Okay, so what are the techniques? You have to acquire the data, you have to do data wrangling. I bring this right. So the next one is explore the data. As I said, the plotting and then visualizing the data. So when I visualize the data, there are two things that I discussed. One is I have to reduce the expenditure during this period of time, because the graph shows that my expenditure is quite high in the first few days and the mid of the month. Or the other one you can think is, okay, I have this lot of money I don't spend during this period of time. I can improve my buying pattern during this period of time. So these are the perspectives that you can look at. So that's called exploring the data. So based on your requirement, you can model the data, and finally you try to visualize the results. Okay, so all these can be done using Python. All right. So why Python? The Python is going to help us through various libraries and the frames, right? Frameworks that it has. So if you want to acquire data, Python is going to help us. This basic NumPy will help us to do lot of vector-based data, all right, categorical data. How we do data wrangling, you have pandas that is available. To explore the data, that is pictorially, if you want to see the data, you can use matplot libraries that are available in Python. And how do you model? You can use, as I mentioned, scikit-learn, NumPy packages will help us to model the data. And similarly, to visualize the data, you can use all these, right? SciPy and so on. So it has rich set of libraries and packages to do data analytics job, which is a part of data science. So another 10-15 minutes we have to wind up. So I will take you through a simple example how Python could be used. And before that, whatever graph that I showed, the same thing I will plot it in Python and show you how you can visualize that data as a graph. Can I do that, Ms. Hannah?
Yes, ma'am, sure.
Yeah. Um, Students, what you have to do is, if you want to work with this, you can use this Anaconda navigator. Okay, these are all open source platforms. So you can just Google and download Anaconda navigator. All right, I have already downloaded. Go for Anaconda 3. Okay, so I have this Anaconda 3, right? Are you seeing the screen?
Yes, ma'am.
Yes,
Yeah.
ma'am.
Yeah. So in that you will see this Anaconda navigator. Don't go for lower versions. You can just go for Anaconda 3 and higher versions. So once you open the file, you will see this circle, that is the logo for Anaconda. All right. You have to wait for it to load. So this has a lot of packages under this. I'm very happy with Jupyter Notebook. Okay, that framework is very friendly to use. It is my opinion. Some use another type of frameworks. It's all how you feel convenient to use. You can use them. Okay, I'll show you what are all available. You can explore any of them. But I'm going to use only Jupyter Notebook. It's taking some time. Yeah. Okay. Are you able to see?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah. So you can use any of these. I am going to use Spider is some prefer Spider because it gives you auto help when you're typing the code. Whichever is you're comfortable with, you can use. So I'm going to launch Jupyter Notebook. So this is the logo that you will see. Okay. So once you open, this is the environment that you will, GUI that you will see. Are you able to see the logo, Jupyter Notebook logo and the list of files?
Yes, ma'am.
Yeah.
Yes.
So when you start this, you can start a new file. Okay. So when you see here, already Python will be installed along with it. Okay. You can open a new file. You can just get like this. Okay, this is the cell in which you can type your code. One cell at a time, you will be able to run the code. Okay, I'm opening the existing one because we are running short of time. So I will open this particular simple example of expenditure, which I have already done and plotted. All right. So are you seeing the code?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
So to plot, you need the comment can be given using the hash. So anything that is after hash is comment. So please ignore. I told you matplot library will help us to plot the curve. So I'm bringing it in line. So this is a code for bringing it in line. And import numpy. All right. So this is the library package that we will be using for handling vectors. See, I have the expenditure of 3 months. All right. So I'm taking the first month expenditure as month 1. So I have here all the 30 entries of data. All right. So all the 30 entries, whatever I showed over there is plotted over here from my presentation I showed you. Let me go to that particular. Okay, never mind, it's taking time. So I will not waste. Okay, so this is the data that we have. And what is the other data? The other column is days. See, you're plotting the expenditure against the days, right? So days should become x-axis to us and the expenditure should come as y-axis, all right? So for that, I have two arrays or vectors, you can say, or lists in Python. So list of 30 entries over here. And similarly, the days. So days is another list of elements, and since it is days, it's starting from 1 to 30. So you can spend time to type all the 30 entries if you enjoy. Otherwise, in short, you can do it with this simple code, right? Line space. So n space, and you have to say the lower limit and upper limit. Up to that, how many elements that you want. So within that limit, how many elements you want. So if you specify that, you will be able to get it. Okay. So maybe I will insert one more cell below or above. Okay, I have entered above. So if I just, I want to insert below. Right. So here I am inserting one simple variable. So d equal to np. Np is what? NumPy. So without that package, you will not be able to use all these methods. So lin space is a method. I told you between a range. So between 5 minus 5 and plus 5, I want some 20 elements. So if I want this, I can just execute this cell. All right. NumPy error. All right, I didn't execute this part. I didn't create this, so I'm getting error. So now it's generated. So if I try to just print that, you will see between minus 5 and 520 entries are there. Are you able to see?
Yes, ma'am.
Yes, ma'am.
Yeah, so it will automatically generate 20 entries between minus 5 and plus 5. So like that, you can just generate. This is only for you all to understand. I'm just deleting this cell. Um, okay. So you can generate the 30 days by one simple line of code. All right. Okay. So I have executed this. You can execute one cell at a time. That is the advantage of this environment. See here, I have 1 to 30 entries. So the days are there. So if I want to plot, just use this plot method of matplot library. Okay. So you have here matplot library. From that you have imported this package pyplot. So I'm calling that as PLT. So I'm using this PLT.plot method. So there are two entries that I'm passing. One is the x-axis entries and the other one is y-axis entries. So if I give this and execute, I'll be able to see the result. Okay. So this is plotting for 1 month. So if I want for all the 3 months, month 2, I have this next set of entries, month 3, the next set of entries. And if I just plot, all will be blue in color. So I'm giving for each month one color. So plot days month 1. The color I want is for, I think, April, May, June. So for April, you can also give titles, legends and other things to the curve. So R is for red color for the month April, the first month, green and blue. So when you execute this, you will be able to see the plotting. So this is the curve that I have inserted into my presentation. So are you understanding this? So,
Yes.
so is it not so simple, Python?
Yes.
Yes, very simple to use, easy to use. All right. So now let us come back to our example. Do we have time or we have to wind up, teachers?
Ma'am, maybe another 10 minutes, ma'am.
Another 10 minutes. Okay. Right. So then I will quickly go through this particular example. All right. Okay. See, this example is to basically build a neural network model and how you can use that model to study the data and make predictions. Okay. So there is a person who measures two types of seeds. One is blue color seeds, and then the other group of seeds is red in color. All right. So they are measured based on its length and the width of the seeds. So there are two attributes that helps us to understand this. So it started measuring so that he can build a classifier. All right. So the features are length and width. So this red color seed has length 3 and width 1.5. Similarly, blue is plotted over here and so on. So once he finishes measuring all the things, taken the data, and he notices that this particular entry he missed out to see whether what color seed is that. So is there any way of using the data that is available to predict what color the seed is going to be, which is of length 4.5 and which is of width 1? So as I mentioned earlier, the best way to start is plot one side length, the other side width. So that's what he has done over here. So here is the width, and y-axis he plots the length. So when this data is plotted, you see that all the blue ones are over here and all the red ones are this side. So it is basically clear kind of separation. Now the one he doesn't know falls under this red side because 4.5 and 1. So definitely he can immediately decide that it is going to be a red color seed. But it's not going to be always so easy. So what if it is going to be somewhere in between? Very difficult to decide. So how do you build a model for this so that the same thing, set of attributes, if you give it to the machine, it should be able to act as a classifier. Okay. So this model is called neural network. Okay. So you have two inputs. So we have M1 and M2 as inputs, and you want the output to be either red color or blue color. So this red, we have to quantify all of them. So you cannot say that red and blue. So we can associate a number for red and we can associate a number for blue. So suppose anything I get, because it's going to be yes or no, right? So anything that is blue, we can take it as 0. Anything that is red can be treated as 1. Okay. So how do we build this model? So we have two inputs, M1 and M2, which are nothing but length and breadth. These are the attributes. All right. So we have to have some kind of uh, weights associated to these inputs. So let me call it as W1 and W2. So we build a model by multiplying this M1 with W1 and M2 with W2, right? And try to add a bias to it. So this is going to be basically your network model. Now this is going to result in any value which is going to be a general numerical value, which could be negative sometime, it could be positive sometime. And when you add all of them, it's going to be some value on a real number. Okay. But we are not interested in all the range of values. We want to confine to a particular range. So we want to bring it to either 0 or 1 or some value between this. So that means the value that we are getting as an output should confine between 0 to 1. So how do we do any real data converge to a value between 0 and 1? That is called activation function. So we use the sigmoid function on this model so that when you apply the sigmoid on this expression, the value will converge between 0 and 1. Any value that you put over here will converge to a value which is in the range 0 to 1. So it will be easy to decide if it is closer to 0, the result is closer to 0, then it will be a blue color seed. And if it is closer to 1, then it will be a red color seed. Okay, so we know that this is the expression that we are going to use, and that is going to act as a model. Now we know the inputs. What are the inputs? M1 and M2. But we don't know what is this W1, W2 and B. So these are called parameters, learning parameters. Okay, so these should be started with some random values, and you have to go through a lot of iterative process. And for example, you give M1 and M2 as a value that you are seeing over here. See, M1 is 3 and this is this. And you understand with some random values of W1 and W2 and B, what is the value that you are getting. If you are getting something close to 0, that means it is going to be a correct prediction. Suppose you are getting the result something above zero 0.5, that means your prediction is not correct. So in which case you have to adjust this W1, W2 and B and try to learn the model in such a way that ultimately you will be able to predict what is blue seed and which is red seed correctly. So this is basically all about neural network model. So we have M1, we have M2, which are the inputs, which are nothing but length and breadth. We do not know what is W1, W2 and B. That should be learned through machine learning algorithms. So here we are using neural network model to learn that W1, W2 and B. So how do we learn? What is the metric that we will use, whether we are going in the right learning path? So for that, we need something called cost. So the cost is nothing but the one which minimizes the error. All right. So if I need more time to explain, if I have to explain in detail, okay. So for example, you have the data M1 and M2 and you run through the model and you try to predict. So suppose it is predicting correctly, then you're okay. Suppose it is predicting wrong, then comes the error. So your target is blue, but it is predicting something else. So that means it is wrong, right? So that is called an error. So you expect something, but the prediction is, whatever you're expecting is called target, and whatever you're getting actually is called the prediction. So the difference between the target and the prediction will be called the error. So if it is prediction is correct, then the target and your arrived result will be the same. So that means the cost is 0. Whereas that means the error is 0. So if the prediction is different from the target, that means there is an error. So you have to minimize the error and try to achieve the model. Okay. So to do that, you need some kind of mathematics. And so as I mentioned, you have a prediction and you have the target. So the difference between the prediction and the target is called error. So if I square that error, that is called mean squared error. So we have to minimize the mean square error in our network model so that you will be able to achieve the model precisely. Okay. Um, Right. So how we can do that in Python? I will take you through this example. That's our last example. I think we are running short of time. I'll open this file. Hmm. Are you able to see the notebook?
Yes, ma'am.
Yes.
Yeah. So import NumPy. This is a package. So as I mentioned, the model, neural network model I have defined over here. What are the things that variables that were there? M1 and M2, which are the inputs. W1, W2, and B are the parameters. All right. So our model is nothing but the Z, right? Which is nothing but W1 into M1 plus W2 into M2 plus B. All right. So this is your Z, and that I'm submitting to sigmoid so that it will converge between 0 and 1. So what is sigmoid function? Sigmoid function is displayed over here. So I'm just running each cell. So now I have run this cell. So as I mentioned over here, W1 and W2 should be random values. See, I'm running this. So this is the random value that will be generated. So if you want to list and see what those random numbers are, you can insert a cell below and just print what is W1 and I execute. So the random value chosen for W1 is 0.75. So similarly, you can print each of them and check it, what this value W2 you can check. So 0.172, and similarly you can print B and check it. So these are the random numbers generated. Now use that as, so the first data that I have is 3 as the width and 1.5, sorry, length is 3 and 1.5 is the width, and W1, W2 and B are chosen randomly. So now I'm calling this NN by passing these arguments. What is NN? These are, this is how you define a function. So this is all, this is a function in Python. DEF is a keyword and name of the function, parameters and 1 colon and indentation. Okay. So I'm calling that function over here using these parameters. So what do you see? You see 0.8. So actually 0.8 means it is red. So that means our prediction is wrong, isn't it? If the value is below 0.5, then it is going to be blue flower. All right. But I'm getting it worth 0.87. Are you understanding? Are you able to understand?
Yes, ma'am.
Hello, student.
Yes, ma'am.
I'm just projecting the data. It's taking some time. Yeah, see here 3 and 1.5. Oh, it is red only, sorry. 3 and 1.5 is red only. Are you seeing the data? Are you able to see the data here?
Yes, ma'am.
Yeah, I took M1 as 3 and M2 as 1.5. It predicted to be 0.8. So it is a red flower only. 0.8 means it's closer to 1.
Red.
So that means it is red. Correctly it is predicting. But you cannot conclude that the model and the weights are correct. So you have to keep doing this by minimizing the cost. Since I don't have time, I won't be able to show you how to build the cost function and reduce the cost. Maybe I will just show the Python code alone for you and wind up. Okay, since already it is crossed your duration. See, this is the same example. Are you seeing the data over here, the entire set of data? 3, 1.5, that means the class. This is the classification problem or supervised learning method. So the labels are also listed over here. This third entry is nothing but whether it's a blue or red flower. While learning, I'm already telling that which category it belongs to. So if it is 1, it is a red color seed, and if it is 0, it's a blue color seed. So the data has been supplied to the model. As I mentioned, W1, W2, and B are here, right? The sigmoid is built, and finally, you will be able to minimize the cost and get your prediction. Okay, so this is all about Python and how you can do data modeling with Python and predict the data and improvise your business models. So I would like to stop over here. Sorry for exceeding your time. Thank you, Ms. Priya and Hannah, and all the students for your patient listening, and hope uh, you could take something out of this session. Thank you to all of
Thank you,
you.
ma'am.
So any
Thank you,
queries
ma'am.
you can just, I'm ready to answer.
Thank you, ma'am, for such a wonderful and enlightening session. And thank you for explaining the concept with a lot of